Let's be honest for a second. If your entire understanding of AI engineering right now boils down to writing better prompts, calling OpenAI APIs, or blindly copying a LoRA fine-tuning recipe from a GitHub README, you're playing on easy mode, and that easy mode is about to get completely automated away. The frontier of AI has shifted. We've officially moved past the black box era, where you just throw text at an API and pray. The engineers making the real money right now, the ones building high-throughput systems, custom inference engines, and local edge deployments, they aren't looking at prompts, they're looking at architecture. But here's the problem. Models aren't just stacking 12 transformer blocks anymore. We're dealing with sparse mixture of experts, hybrid attention mechanisms, and insane multimodal projection layers. Trying to understand a modern 70 billion parameter model by reading a raw text config file is like trying to understand a skyscraper by staring at a plumbing blueprint. It's impossible. Your brain doesn't scale that way. So today, we are doing a reality check. We are breaking down the two completely different tools people mean when they say HF Viewer. First, the built-in Hugging Face tool that lets you query terabytes of data without downloading a single byte. And second, the new third-party visualizer that is blowing up because it turns unreadable code into interactive model graphs. If you want to survive the shift from a wrapper developer to a systems-level AI engineer, drop the prompts for the next 15 minutes. Let's get into it. Alright, let's start with the tool built directly into the Hugging Face ecosystem, the Dataset Viewer. Now, if you're a junior developer, you probably think Hugging Face is just a glorified Google Drive for datasets. You click download, wait 3 hours for a 500 gigabyte file to hit your local drive, and then realize your local machine doesn't even have enough RAM to open it. Senior engineers don't do that. They respect data gravity. Moving huge chunks of data across the internet is slow, expensive, and stupid. The HF Dataset Viewer is essentially a lightweight data warehouse living right inside your browser. Under the hood, whenever a dataset is uploaded, Hugging Face automatically converts it into optimized Parquet files. Because of that, the viewer gives you 5 killer features you should be using before you write a single line of training code. 1. Instant slicing. You can paginate, inspect columns, and expand nested JSON fields instantly, whether the dataset is 10 megabytes or 10 terabytes. 2. Multi-modal preview. If it's an audio or image dataset, you don't just see a file path. You can play the audio and view the images straight from the browser UI. 3. Real-time distributions. It automatically computes lightweight statistics and histograms. Want to see if your training data is severely class imbalanced? You can check it visually in 2 seconds. But here is the most underrated feature that almost nobody talks about. On the browser SQL console. Because Hugging Face turned everything into Parquet, you can write literal SQL queries against a remote dataset directly in the UI. Look at this. Select text, label from train. Where label pronseju positive. Limit 10. You run it, and boom, instant results. You didn't download anything. You didn't write a pandas script. Think about why this matters for real-world engineering. If you're building a RAG pipeline, you can sample documents to check formatting before embedding them. If you're generating synthetic data with an LLM, you can use the viewer's API layer to build an evaluation dashboard to spot hallucinations before that data taints your training run. It's not just a viewer, it's a managed data registry. Learn it, use it. But now let's talk about the tool that is actually blowing up online right now, the one changing how we reason about models. It's a third-party tool called hfviewer.com. If the dataset viewer is a map for your data, HF Viewer is an X-ray machine for your models. When you look at a model's repository, all you get is a text file called Config.json, and like I said, that doesn't scale anymore. When you paste that model's Hugging Face URL into hfviewer.com, it parses the architecture metadata, traces the module graphs, and renders it as an interactive, live graph. Instead of reading boring parameters, you visually see the attention routing flows, the encoder-decoder topologies, and exactly how multimodal paths merge. And here's a pro tip, the URL replacement trick. If you're looking at any model on Hugging Face, just go to the URL bar, delete huggingface.co, type in hfviewer.com, and leave the rest of the path identical. Hit enter. Boom, instant architectural visualization. One of the best features here is the granularity control. You can zoom out to see the macro architecture or use the slider to slide deep down into the block-level components and traced internals. You can even do side-by-side comparisons of different model families, like comparing different Quen variants or Gemma versions to see exactly what changed between iterations. Now, a junior dev looks at this and says, "Wow, pretty colors, neat lines." A senior systems engineer looks at this and says, "This is my optimization blueprint. Let me show you exactly how you use this graph to save thousands of dollars in compute." First up, quantization planning. When you take a massive model and crush it down to 4-bit or 8-bit precision using AWQ or GPTQ so it can fit on cheaper hardware, you cannot treat every layer the same. Some layers are incredibly sensitive. If you quantize them, the model's brain melts and it starts outputting gibberish. By looking at the HF viewer graph, you can visually trace the bottleneck modules and the down projection gates. You can literally map out your strategy. I'm keeping these specific attention layers at FP16, and I'm aggressively dropping these repeated block layers down to INT4. Second, fine-tuning strategy. Most basic tutorials tell you to just blindly slap LoRA adapters onto your attention projection layers, QProj and VProj. But what if you're working with a vision language model? Where do the image embeddings actually inject into the text stream? Is there a cross-attention layer, or are they just concatenated? HF Viewer shows you the exact crossroad where those two modalities collide. That is exactly where your adapter has the most leverage. It's also an incredible educational tool. If you are trying to truly understand how Mixture of Experts, MOE, works, how a router selects 2 out of 16 experts dynamically per token, seeing it visualized as a live graph does more for your brain than reading a 30-page research paper ever will. But look, let's wrap this up with a ruthless reality check. Because a map is not the same thing as the actual traffic. As incredible as HF Viewer is, a static graph cannot show you runtime execution. It won't show you if your inference engine is successfully fusing kernels using flash attention. It won't show you the exact milliseconds you're losing to VRAM bottlenecks or GPU communication delays in a tensor parallel setup. For that, you still need profiling tools like PyTorch Profiler or NVIDIA Nsight. The big picture here is clear. AI tooling is rapidly evolving away from text configurations and toward visual, graph-native intelligence. The Hugging Face Dataset Viewer solved the data gravity problem, letting you inspect terabytes without moving them. HFViewer.com is solving the cognitive complexity problem, letting you understand billions of parameters without losing your sanity. The gap between the developers who just write prompts and the engineers who actually understand architecture is widening every single day. Don't get left on the wrong side of that gap. Stop guessing based on JSON files. Pull up the graph, inspect the routing, and start engineering at the systems layer. Links to both tools are in the description below. Go build something real, and I'll see you in the next one.